Hello, welcome to Properties of Logs. So just a quick reminder, we can rewrite log base 10 of 100 equals x as 10 to the x equals 100. We know that 100 is actually 10 squared, so x equals 2. Now, whenever you have just log written, you have to assume that it is base 10. That's an assumption that's made. So here, we actually have log base 10 of 1 equals x. So let's rewrite that. 10 to the x equals 1. Now, what exponent can we have for 10 where it's going to equal 1? If you remember your properties of exponents, that exponent has to be a 0. Whenever a number is raised to the 0 power, we get 1. So therefore, x would equal 0. So the first property is log of any base, it doesn't matter what base, of 1 is going to equal 0. That is our first property. The log of 1 equals 0. Now, our second property, we look here, we have log 10 equals x. So remember, we have that base 10 there. So 10 to the x equals 10. Now, we know that there's a 1 there, so x equals 1. So here, log base b of b, because our 10s were the same, so if it's the same, equals 1. That is our second property. If the base and what you're taking the log of are the same, then it will equal 1. Looking down, we see log base 10 of 0 equals x. So we're going to know that that 10 is there. So we say, okay, 10 to what exponent is going to equal 0? If you remember the exponents, this can never happen. If we do negative exponents, we get fractions. We never get 0. So this does not exist. You cannot find the log of 0. If we move down, we get into natural log. This is when we have base e. So it's the log base e of e equals x. The natural log, ln, just means log of base e. So here we have log of the same base as what you're trying to take the log of. If we remember here, if the bases are the same, the base and what you're trying to take the log of is the same, then it equals 1. So the natural log of e is equal to 1. That goes along with log base b of b equals 1, because it's the same thing. Now, a new property that we have is when you're squaring something or raising it to some power, having some exponent there, you can move that exponent to the front. So we're going to rewrite this as 2 times natural log e equals x. Now we know that the natural log of e equals 1, so 2 times 1 equals x. So here x equals 2. Okay, so that is our third property, is if you have log base b of a and it's raised to the c, we can rewrite that as the exponent c times log base b of a. Okay, so that is our last property. So let's look at another example with that. So here we have log 5 cubed equals x. So we're going to move that 3 to the front. So 3 log 5 equals x. And then because this is base 10, that's the normal common log, that's common log, we can use our calculator and find what that actually means. So if we type it into our calculator, we get x equal to 2.0969. And we'll just say that's approximately. Okay, so to kind of go back over. Our first one is the log of 1 equals 0. Second one, if the base and what you're taking the log of is the same, then it's 1. Log of 0 does not exist. Natural log of e equals 1, so that goes along with the base b of b. And then the final is when you have an exponent that you're taking the log of, you can multiply it in front. So here are a few to try on your own. So I'd like you to try these last ones. So log 6 squared equals x, and natural log 3 to the 5th equals x. So I'd like you to rewrite it using the properties and then solve with a calculator. Thank you.